This video explains decision tree idea. Decision tree is a visual tool that we can make decision effectively. So this is a good visualization tool. And basically there are two different type of node. One is a decision node, the other one is event node. Decision node, we use a square, and this square we can make decision. Means this is from our side. Event node is a circle. Circle can be used for event node. Event node's case, we cannot control. So actually there must be some outside event. That means we cannot control. There must be some possibility or scenario, different type of scenario, but we have probability information. And basically we have to use these two different type of node, decision node, event node. And when you construct decision tree, so we can start from left and we can move forward to the right, and at the very first we can use a decision point, and then we can develop some branches from there, and we can represent, if we have any kind of decision, then we can use a square. Otherwise, if we have some other event or outcomes, then we can use a circle and we can make some branch. So also at the same time, we have to assign probability to each branch. And if we have a decision tree, and now we have to solve this decision tree. How? We have to roll back, and we have to move back from the end of decision tree, means leaf. So we have to start from final branch and final leaves, and we have to evaluate backward to the root node. And if we have a decision node, then we have to choose the best one. Otherwise, if we have event node, we have to calculate the expected value of each branch. So that's basic ideas. And we will solve one problem. Before we start this problem, you have to understand this problem. Please pause this video and please read this problem. So this problem is in-class example. So Michelle, like you, and she want to get some internship, and at very first time, and her father's friends has operate some small business, and her father's friends offer internship, and the salary is $4,005. But for this case, there is no other possible scenario. So you can decide, or you can Michelle can accept this offer or not. So there is only decision node for at this point, and there is no kind of probability or event case. So this case we have only two possible scenarios. So now we can draw this decision node. At the very first, we can start this node A. We have accept offer or reject offer. So we have this possible, two different decisions. Means actually we can start square, not circle, square. So with this circle, we have two different options. When you construct decision node, please write down your option decision on this arc. And when you accept offer, then you can, this is your final branch, means final leaves. So this is your final payoff. And then next, she might have another option. And Michelle's faculty advisor mentioned to her there must be some, internship from supply chain center in this fall, and the due is July, and the offer will be made in August, and the salary is 7,000. But for this case, she cannot get this internship directly 100%, but there must be some chance. So because some other application will be admitted, and advisor will decide right? Then there must be some 70% of chance that she will get offer. So at this point, she has some probability. She at this point she reject offer, and what is next step? And next step and next decision will be she will apply to supply chain center or to not supply chain center. If she applies supply center, and there must be some event. So here A and B are decisional, so that's why we use square. And for C, event C, actually there is some chance. I mean, getting internship 70%, rejected 30% if she get internship, and you have to write this, payoff at the end. And back to this problem. So now we have 70%, 70 chance of internship. So that means you have to specify, you have to assign this 70% and 30% for rejected, being rejected. And now next step. So this is sequence based, I mean time based. So next, Michelle has another opportunity to attend the internship fair job fair in College Business in September. And last year there is some information. Last year there are this kind of information. 25% student receive 7,500, 25% receive 6,000, 24,000. I mean, also there is some chance that you do not have any offer. So we have 4 different possible scenario. Then we can make decision tree. You can add this decision tree here. So here, if she doesn't have any internship or she does not apply supply chain center, and probably she wanna go to job fair directly. So then we have event node D and E. So D, event node D and event node E are identical. They are same. And also there we have to assign, you can provide these name, high salary, medium salary, low salary, no salary. And also you have to assign probability like this, 25%, 25%, 20%, 30%. For each case, you have to define, you have to specify the exact amount of money, payoff, benefit, or loss, right? So we have done step one. Step one means you just complete decision tree construction. We just constructed decision tree. So step one is done, and then now we have to roll back. And how can we roll back? So to roll back, and you have to start from here. You have to start from this area. You have to start from here, right? So when you roll back and you face with this event node D, event node E. So actually event node D and E are the same, so identical, but actually D and E, you have a probability and their payoff, then you have to compute the expected value. How can you compute expected value? So you can compute the expected value like this, 25% times 7,000 plus medium salary, again 25% times their value 6,000 plus low salary 20% times 4,000. The other is 0. Then what is this number? So please compute this number. So if you have a calculator or Excel, you can compute this number. This is actually expected value for event node D and E. So we will move. And actually that number is 4,175, 4,175. Then now we roll back one step, and now you have to roll back here. So to roll back, and you have these two numbers. At this point, you have event node C again, and you have this probability. Then what is the expected value for event node C? So if expected value will be 0.7 times 7,000 plus 30% times 4,175. So compute this number. What is this number? So you have to compute the expected value for event node C. So please compute. Then this number is 6,153. And then now you have to roll back, and to roll back, so you have to take into account this C and E. So if you have C and E, so at this point there is no probability, because this case we face with what? Decision node, not event node. For decision node, you have to choose the best one. So which one is best one? Which one is better one? So here 6,000, expected value 6,000, here 4,000. Then you can choose this number. So you can choose this number. Then you have to take out. So then you will decide that this number is your outcome for node B. So node B, you can recognize this node B has what? This number. This number is from this. So actually for event node D and event node E, event node C, you have to compute expected number, but decision node B, you have to choose best one. So that's different. So now we are done up to event node B, decision node B. Then now next you face with decision node A, that you have to consider these two value. So you have 6,000 and 4,000, right? 6,000, 4,000. Then out of this, which one is better? So actually this number is better. So that's why you can write here 6,153 here, and you have to take out, you have to prune this no. So finally, at the end, this is your conclusion. So you reach to a root node A. That means this is your final conclusion based on this. When you, at the very first, you have to consider this decision node, and then now you have to roll back. And when you roll back, so for event node, this event node, you have to compute expected value. For decision node, you have to choose the best one. Finally, we reach to root node. So now you have to interpret your conclusion. So actually, what is your best strategy? Your best strategy is here from decision node A. So you have to choose 6,000. Where is 6,000? So here, right? So this is your best decisions, right? And then here, so you have to choose what? You have to apply to SCC. So your best scenario is what? You do not accept your father's friend's offer, but you have to apply SCC. Then your expected value, average number is 6,153. But however, there is some possible scenario. So with a 70% of possibility, you can get $7,000. Otherwise, if you do not accept, do not get any internship from SCC, then probably you can go to job fair, and the job fair you have what? This is highest salary that you can expect, right? But the scenario is only 25%. Also, you have a medium salary, $6,000. This is actually better than your first offer, right? So, but the possible scenario is 25%. but also you might have only 4,000. This is less than your first offer, but that possible scenario is 20%. At the same time, you have a zero salary. You do not have any internship, but that possible scenario is 30%. So that's why you can choose what you reject this offer, your father's friend offer, and then you apply SCC. Then you expect 6,153. But if you are very risk avoid or risk not risk prone, I mean risk averse people, then probably you can accept this offer. That's possible scenario. But if you do not want to have this no salary case, then probably you can accept this possible scenario. But however, for this decision tree case, we can use what? We can use expected value idea approach.